It is time, so we'd like to now start the press conference. Let me introduce who are on the stage. From the right-hand side, Hayabusa2 Machine Manager, Dr. Makoto Yoshikawa. Project Engineer, Takanao Saeki. Project Manager, Yuichi Tsuda. Project Scientist and Nagoya University Professor Seiichiro Watanabe, Professor Seiichiro Watanabe. And spokesperson, who is Professor Kubota, Takashi Kubota. Then Project Manager Tsuda. Could you stand over there, please? Sorry for poor proceedings. Good afternoon, ladies and gentlemen. It started to rain just now, but thank you very much for getting here. And touchdown operation has been observed by you, and pay attention to that. Thank you very much. Hayabusa2 today executed a second touchdown, and we were able to obtain the history in the solar system today. From this point on, allow me to read the text. JAXA, Hayabusa2, the steroid explorer Hayabusa sent to Ryugu, and then we were able to gather the samples. And when we checked the data from Hayabusa sample collection projectile, the firing the projectile as well as the sequence has been conducted. We are able to confirm that. Hayabusa2 right now is in normal operation, and the second touchdown to Ryugu was successful. In order to conduct this operation, Hayabusa2 project team worked on this, but that was not enough. Overseas, the NASA in the USA and project partner DAR, CONES, Germany and France. In Japan, JAXA, other than JAXA, there are many institutions that extended cooperation to us. And the reporters who continue to report on this operation, the mass media personnel, as well as the people of Japan, as well as the people all around the world who paid attention to the second touchdown over Hayabusa. I'd like to express my thanks to all of you. We'd like to share this success with all of you. Thank you very much. Then next, starting from yesterday, descent started, and up until operation, including touchdown, the project manager Saeki is going to explain that. Project engineer, excuse me, Saeki is going to explain that. I'm project engineer Saeki. Let me talk about the operation which started from yesterday. Next page. This is the one-day operation diagram. The descent started yesterday. At around 11, the descent started on the ground time, and it was as scheduled. There's no delay. 40 centimeters per sec was the speed for descending. And just like normal operations, 5 kilometers was the speed at which the descending started. And then from there, it's 10 centimeters per sec to get down to the 30 meters altitude level. And from that point on was autonomous operation. And 30 meters arrival was the telemetry receipt time was 9:54, and we checked the time. And after that, autonomous operation was done 10:06 according to the spacecraft. Some platform was able to touch on the surface of the Ryugu, and then immediately after that, the rising took place, and it keeps rising. The rising speed will be decelerated to get back to the home position, which will be tomorrow. It is expected to return to the home position tomorrow. Then the next page. This is 30 meters or lower level sequence is described in here. At the altitude of 30 meters, when it reached there, the altitude need to be maintained at a certain level. That is called hovering. The target marker should be able to be captured during that time. In order to do that, the camera is mounted. 9:47, it started to capture and then once the camera was opened, and then the target marker was able to be captured. Once it is captured, then the spacecraft continues to take a look at it, continue to descend, and then the sensor, the altimeter was switched to LRF from LiDAR. And at 8.5 meters, the descent stopped, and then the hovering started again. During that time, the altitude was tilted a little bit. The target marker, we have a position where we decided in advance, and so we guide the spacecraft over there. Then at 10:03 or maybe slightly later, around about 10:05, and the final descent was conducted at 10:06. On board time, the spacecraft sampler touched the ground. So at this timing, the projectile was fired, and the rising started. And so we were able to confirm all this with telemetry and Doppler. And the next one is the summary of all the events. In the time of a descent, there are several checkpoints. The first descent is the gate 1, where the spacecraft started to descend. That was about 10:30 yesterday. And then gate 2, last night about midnight. Then gate 3, this is the go or no go judgment. At around 9 o'clock, that was done. And then from that point on is autonomous sequence. So antenna switchover was taking place as well. Then the final touchdown on board took place at 10:06. Then after that, in order to see the telemetry, we switched the antenna 10:39. All the sequences are properly working, and so spacecraft is properly operating. We were able to confirm that. Now this is the touchdown was properly conducted. This is one of the evidence of touchdown was properly done. Just like a previous case, projectile, the explosive powder will be operated, and then the temperature goes up. About 10 degrees temperature went up by 10 degrees, and so the explosives was fired as planned. Up to this point is today's the summary of the operation of yesterday as well as today. The next slide is touchdown. Immediately after touchdown, this image was captured. So Dr. Watanabe is going to explain this part. I'm Watanabe. Then could you show the next slide, please? Immediately after the touchdown, this image was captured. At this point in time, the touchdown time, it says 10:06 or 20 seconds, or that has not been finalized yet. And the surface condition is not clear at this point, and so we don't know the exact altitude, but it's about 10 meters, or slightly less than 10 meters. And so this is an assumption at this point in time.
This is taken from the surface of the Ryugu, where this is exactly the point within the range of 1 meters from the original touchdown points, which we expect to happen according to our estimate at this point. There are several rocks at the bottom, at the above. That was the one of the marker where we were used as a reference, and we were able to land with the high level of accuracy. As you can see, overall, these were almost all rocks and stones which were elevated from the surface. So as you are aware, the surface of the Ryugu was covered by many rocks, and we launched the projectors and also put the thrusters in, and therefore even in the first touchdown we were able to see all these dusts flowing around the air here, but we have actually obtained different feeling at this point, and therefore depending upon the area which we landed on, maybe the size of the particles and composites are quite different, and probably that creates the all difference in the feelings in our side. So we are looking for the scientific analysis. So a white lighted area is the rock, and dark area is the shadow, and therefore it looks very dark. Now, 2 minutes after the first touchdown, where the altitude is about 100 meters, and the range of this screen is about 1 meter per line, per direction. So here you see this previously was augmented, expanded in the earlier photo, where we were only showing a very narrow range, but now we have probably 10 times a large area where which we are taking a photo, where after the touchdown, the Hayabusa2 was once again ascended, and therefore we take a photo from 100 meters. So ejectors and thrusters have created some dust, and there are some scratches on top of the surface, so mixture of these scratches and dusts are creating this darker area. That exact point is actually that very close to the crater created by SCI, and in fact here is the crater which were produced at the 5th of April, produced by SCI. Center of the crater locates here, and it's only is away from 20 centimeters, 20 meters or so. So SCI crater emitted some particles, and we estimate that such particles are accumulating in this particular area, and therefore we decided to obtain the samples in this particular area so that we would be able to sample the subsurface materials, and we were able to make that theory, and because our operation was perfectly conducted, and therefore we expect that we can obtain some subsurface samples. Well, then we'd like to move on to the question and answer. If you have any questions, please raise your hand and wait for the microphone, which we will be bringing you. And please raise your question after receiving the microphone. The person in the white jacket, please. This is Ida of Nippon TV. I ask a question to Professor Watanabe. May I just confirm that this particular photo, the center darker area, that exact point was the second touchdown. Is that correct? Correct. It is quite broad on the photo. Therefore, we are not sure what exact point that the horn of the sample taker have landed on the surface. But as a result of the dust created this touchdown, we have a location of exact touch point. I ask the question to Project Manager Tsuda. During this mission, what is your score of this mission? What is the full mark? What should be the full mark? Out of 100 being a full mark, I would say 1,000 score that I would like to give, because nothing that I need to complain. Everything moved perfectly, and the team's preparation beforehand, inclusive of all, it was a perfect operation. So 10 times of a full mark of 100. Yes. So it's 1,000 score out of 100 of a full score. Next question, please. The person right behind the lady. Right. This is Tokyo Tobimono Gakkai. My name is Kanaki. I raised question to Dr. Tsuda. During the first touchdown, as well as CI operation, and this is a touchdown too, you go through very difficult operations. So looking back at TD1 and SCI, were there any differences in the mindsets when you try to make this second attempt in touchdown? During the first touchdown, as well as SCI operations, these were for us, and in regard to the whole of the operation of a sample return of Hayabusa, that was the very first attempt and initiatives, and therefore we believe that there must have been great steps. What is different this time is this is the touchdown the second time, and therefore the condition of the explorer as well as the planning. We had both options of refraining from this operation and also go ahead with this operation. So therefore, we were able to create and structure this operation as such, and that is quite grateful. And among the two options which we have, whether go back or move forward, we evaluated based on the technical and scientific decisions, and we were able to move forward with the second touchdown. We were able to make such decision this time. This is exactly the usefulness and the significance in regard to the scientific, technical, and operation point of view, and this is quite a significant step for us. We were able to make this type of decision. Our team is capable of this kinds of decision. We were able to demonstrate this clearly to the world, and that is something that I'm greatly proud of. Thank you very much. The person in the dark blue jacket, please. This is Takai of NHK. I raise questions to Dr. Tsuda. Dr. Tsuda, I am here. So far, in the sequential way, you were able to make a great success. What is your secret to this success? What do you think is the secret of success? Teamwork is the only factor contribute to the success. All of the members here on the table today and dozens, about 40 or 50 members are in the control room, and every one of them played significant role, and they have accomplished the mission that need to accomplish. And be it SCI, be it touchdown, everything was operated quite well. On top of that, though, during the touchdown too, there were some self-criticism capability that demonstrate effectiveness. When we work on the touchdown too, everyone were very careful in operating their tasks. We had a lot of meetings, and there are so many calculations and computation involved in this efforts. And everyone were really nasty and sometimes too critics, and they made a very thorough simulations, and they come up with a very narrow risk of having some incidents or accidents, and we narrowed down that risk to the extent possible, and we thoroughly covered all kinds of risks. And this is outrageous level of self-criticism. With that, we were able to have a very smooth operation in today's operation, where nothing wrong had happened at all. And I think this is just an outcome of all the efforts made by the team members. Another question. You said that we were able to obtain the source of the history of origin of the history of a solar system, and you probably are likely to bring back all this evidence back to the Earth. Maybe the earlier comment was too much of a exaggeration. I might have been able to have a fragment of the origin of a solar system, which means that we were able to obtain the subground samples. Well, think about the subsurface material sampling. Other than moon, we were able to obtain. We were not able to obtain at all other than moon, and it's not a single point sampling, but we have the surface materials as well. In order to compare with the subsurface material during the touchdown one, it is just a several centimeter differences from the targeted point, and we were able to obtain a sample from the deep from the subsurface. Think about the history of the solar system, and also think about the origin of the solar system. That exactly the objectives of Hayabusa2, and we were able to obtain a very precious samples.
And next is to bring them back. We have captured the sample. We must make sure that it comes back to Earth. So we need to, of course, continue with the operation properly. Just the person in front of the previous person who asked the question. Uno from Pinpoint TV. I would like to ask Dr. Tsura. Towards the end of February, you were successful in the first touchdown, and there were risks, of course, in making an attempt towards the second touchdown. So, in what way have you judged to go ahead with the second touchdown? Whether to bring back the outcome from the first touchdown only, or to give it another try? Were you in mixed minds? Were there any difficulties in making that judgment? Well, this was a judgment stage that we have never experienced in other missions. We were not in a position where the backs were pushed against the wall. We already had a success, and we were in a position of going for even further success. There were no negatives, so it's going to be plus or zero. That was the kind of a position that we were in. And in having this discussion, we did take into consideration the risk of not doing it, excuse me. So we did consider the risk of going ahead, but conversely, there was a risk of not going ahead. So we took both into consideration. We have planned and been saying that we will do a touchdown multiple times, and we were successful in the first touchdown, and we had to make a decision as to whether we're going to do the touchdown for the second time or not. And to do so, or to do the touchdown, is not going to be easy. We made the decision to go ahead, but we were also able to make the decision of not going ahead. But to what extent should we work to enable the mission to do the second touchdown? And this was a matter that was limited only to the Hayabusa2. So we listened to opinions of people outside the Hayabusa2 project as well. And some people said that we should go ahead. Some people said we should stop. And with the Dr. Watanabe and Dr. Sayaki and mission manager Tsuki, and all the members came together and discussed whether we should do the second touchdown. We discussed the values in doing so and values in not doing so. And based on the position that we were in, we made the judgment that we should go ahead with the touchdown. And I understand that the president at the meeting in June kind of put a hold to whether should go ahead or not. It wasn't at that point in time. There was always cautious opinions, even prior to that meeting. In that respect, and we have had this type of discussions from the past, and in that respect, as the project have always indicated a position of what we should be doing against those the concerns. At the operation, the meeting, we were able to confirm our position. Some of the conservative, the opinion that we should give it a hold. Now, what was your position in respect to those comments or thoughts expressed? I thought those were very healthy opinions. Even when we started the project, or even before we did the launch, if we ended up with a success in Touchdown 1, we knew that we were going to be in a mixed position as to whether we should do the second touchdown or not. But what I can do from my position is that we will leave the pathway still available to go either way after doing the first touchdown. And not going ahead is easy because all we have to do is not go ahead. But if we were to go ahead, then we needed to be prepared. And even before arriving at Ryugu, we made preparation with the teams here. And as a consequence, and that ended up becoming very effective. The lady sitting in the front row. Congratulations. I would like to ask Dr. Tsuda, maybe not the right expression, but Hayabusa2 has continued to build up on its successes and have achieved success on each challenge. So in comparison to Hayabusa1, some of people may view this situation as being nonchalant or it's kind of a matter of fact. So, Dr. Tsuda, in what way or how did you think to enable the successive successes? I think people who's been involved from Hayabusa 1 is fully aware and understand. But the technology that's well established is not a drama. It's not going to become a drama once it is well established. Of course, what happened with Hayabusa 1 is something that we understood fully and we have absorbed from that. And as a consequence, what we have learned, they ended up having very positive implications. That was the case for us, and pioneering spirit, if you like. And people recognized the effort, and it ended up being made into a movie. In that respect, that was envious from our perspective. But what we were aiming for as part of Hayabusa2 was not that. We were to establish technology that enables execution without any events. And I think we were able to prove that. And I hope people will be moved by that. I am an engineer, that's what I feel as an engineer. But that type of technology, how did this team capture such technology? How did you nurture that type of technology or technique with this team? I think that there are various parts to this. I think the Hayabusa2 team was humble. And the Hayabusa 1 team, when they did the mission, we are fully aware of their capabilities. And Hayabusa 2 team started from a state that was comparable to Hayabusa 1. We absorbed many things that has enabled for us to get this far. And scientifically, it wasn't just a Hayabusa 2 team. We had the first class, the scientists from around the world who gave us advice, who made direct contribution. This is how we formed our team. Of course, we had spirit of challenge, and there were probably ability to organize ourselves in an appropriate way. But irrespective of how much success we had achieved, we have always remained humble, and I think that was also very important. Lastly, I wanted to ask Dr. Watanabe, when you showed us the pictures, I think you said that it looked different from the first the touchdown. So specifically speaking, what are the differences? Well, I've only had a look at this only several hours ago. So my first impression is that Ryugu, based on spectrum, look the same wherever it is on the asteroid. And so when I thought that when you do sampling, we will end up with more or less same thing. But the volume, the color, or the size of the ejector ended up being somewhat different. So that is small, large, dark, light, and so forth. It may be how the light is shining, but on this occasion, something that is a little bit more brighter tend to stand out. But the previous occasion, more thinner plate type of was prominent. We have some of that, but not exactly the same. But this was my first impressions. Things may change after I look at the data in more detail. But the fact that we did this twice is quite significant. If we only did this once, our image would have been formed based on what we saw in the first attempt. But having done this the second time, there are a variety, even though they may be small, and what type of science lies behind this. So we can come up with many questions, and this was very exciting.
New images available, so let me introduce those then. Sawada-san. My name is Sawada. Nice to meet you. I was not able to make it from the very beginning, but the spacecraft is going back to the home position, and we are making preparations for that. Professor Saiki mentioned about the temperature earlier. At 1:06, the touchdown took place, and the projectile was fired. Now we know the time broadly. So CAMC images show a couple of images. So I took them over here. There are three pictures over here. From the left-hand side, the touchdown time, or 4 seconds before the touchdown. The middle one is the touchdown time, and after firing the projectile, there are very fine particles flying off. And then this is 4 seconds after the firing of the projectile, so you can see that the rise is already taking place. Just like the previous touchdown, and the projectile, flying off various particles such as small size stones and so on and so forth. The scientific interpretation can be done by Professor Watanabe. What was I expect him to do so? Now, while looking at these images, the rock itself, the projector is hitting the rock itself, even though we need to analyze further. So the debris flying off, dust flying off seems to be different from the first time. And so what we were doing as an operation was that the sample catcher, there are 3 rooms for collect the samples. In the current operation, we use the 3rd room. The 2nd room was not used for the touchdown. However, we used this spacecraft, so there may be some small particles contained in the 2nd one. Therefore, we use the 3rd room this time. And while it rises, the former samples can be included in the catcher. So we run the catcher to close the lid of the catcher. So this is too small, so you may not be able to see it, but the sampler's mechanism worked properly, so catcher's lid closed. So we verify that first, and then I run over here. So samplers are probably captured properly, and they are contained in the catcher, and because the lid was already closed. So after that, no samples will be contained in the catcher anymore. So my responsibility as a sampler is to move it to the capsule, to put those samplers into the capsule. So that's something I like to do. So this was sort of a flash report to you. Any impressions from the speaker on the stage? Any members on the stage? Your first impression? Well, I saw this now, so it's very hard to tell. In the first touchdown, I was very much moved. But now, this time, particularly the third picture over here, many things are now flying off. And so Hayabusa2 did something amazing, I feel. Now, of course, the scientific analysis will be starting. We made history, that is for sure. So this wonderful image was captured. That's great. And we are going to continue with the analysis further. So I was very much, surprised. This is very interesting. This one, intriguing. Small sands look like cloudy. Probably the projectile was hit first, and those sands are seen over here after flying those off. The base is rather a big rock over here. It looks like a big rock, so probably that's a rock. And on that, SCI, there are things that were flying from the SCI crater are accumulated, and so those accumulated ones as well as chipped rocks must have been collected. And this is similar to the first one, so large amount of dust can be seen. It's very hard to tell from this one picture, but my impression is that there aren't very many flat ones as compared to the previous mission. So we are going to conduct an analysis of a variety of items over here. So I think that there are a lot of things that we can find, not just by looking at this picture. On this monitor, we are showing the picture. This is a wonderful picture, I think. Hayabusa2 touched the surface of Ryugu, and so this is evidence. And there are many ejecta you can see. So many, I think, amount of ejecta is greater than Hayabusa1, and I think Ryugu is celebrating this mission because it's the second time, I believe. As Mr. Sawada mentioned earlier, already the lid was closed. The lid was closed in the catcher. Therefore, they should be shifted to the capsules to bring them back to the Earth. So it's like a parcel. The box is now, packaged right now. So the lid was closed. So in a steadfast manner, the samples are now expected to be returned to the Earth, and preparations are underway right now for that. And that was successful today. When I look at this picture, this was very impacting picture. When I saw that for the first time, there are too many ejecta, so I wonder if the catcher lid can be closed. But it was reported that the lid was already closed in the catcher, so I believe large amount of ejecta are contained in the catcher. So I look forward to seeing these when it is returned back to the Earth. It was very good. I'm Yoshikawa. I received email, and so immediately I saw this one, the first picture, and second picture, and the third picture. This is really amazing. It's really awesome. The large amount of rocks, small chips of rocks are flying off compared to the first one. And of course, these materials should be brought to the Earth. And so I think a greater expectation can be generated for the analysis. I'm responsible for sampler, so I'm very much relieved. I was able to fulfill the 2 times mission. In the first time, as you know, particularly initially, there were people who were crying, and they were so much pleased. I don't know to what extent other members, particularly who were involved in the first mission, would be pleased. But there are sampler members and also the analysis members are waiting these samples as well. So at least one part of the job is now over. So I would like to continue with the QA. The woman on the second row, please. I'm Hayashi. I'd like to ask Dr. Watanabe and Project Manager Tsuda to Dr. Watanabe. So you were able to obtain some materials from the ground. So in scientifically, what is interesting part? Professor Yabuta mentioned that for organic matters, the subsurface materials are not so much deteriorated and or modified, and so that will be better. So because they are subsurface materials, what can you expect more from those materials, from the subsurface materials? Bringing the samples back to the Earth would be the first one. So the first in the C-type mission, Explorer. So bringing the subsurface materials together would be something that no other countries can do in the coming 20 years or so. So vertical change should be discussed, and that is very important scientifically. And there are what is assumed, and there are many assumptions from the theories as well. But the upper side and lower side, there was not much difference on the upper side and lower side, if that is the case. And then inside of the asteroid is very much mixed as a material. But in the subsurface, the material has something different, something new, and then organic matters and water can contain those materials underground. And so no matter what happens, I think it has a great significance scientifically. And so the second touchdown can bring materials in a manner that we can make a comparison between those two materials. That is the greatest achievement, I would say.
On the other hand, you already captured a lot of treasures during the first touchdown, and attempting for the second one, you had some risks of losing the first samples, and there were some discussions. And what was your opinion in the first place? Think about the risks or the possibility of bringing back two kinds of samples, and what were your assessment? Well, OSIRIS-REx, which is a U.S. initiative that we are conducting in the same manner, where there is a mission to the C-type asteroid. Major differences that Hayabusa2 will conduct variety of things, activities. And it seems as if that the Hayabusa2 had been engaged in many different things. However, all these different activities are organized in a meticulous way. SCI, the impactor creating crater and ejector is flowing around, and we take the sample out of it. So in order to make great success, we need to land on the Minerva and Mascot rovers so that we can analyze the surface structures, and we have to think about where to land. So all these actions are sequentially continued, and therefore because of this, touchdown 2 is quite meaningful. Integrating all of the knowledge and assets are integrated into one, and this is quite a great cornerstone that we were able to achieve for the first time. So you were in favor of the second touchdown. Well, in favor, what do you mean? Well, idea of the second touchdown, were you in favor? I was willing to do this. However, of course, we need to mitigate the risks, and engineering teams have discussed quite thoroughly, and we were able to make a great success like this one. Thank you very much. Next, Project Manager Tsuda. in earlier comments of yourself during the landing of the touchdown, first, that was the adventure per se. And this time around, you had options, choices today, and you selected one choice out of multiple and move ahead with a particular choice. And that will be quite useful for the future exploration mission. And how do you connect the success this time to be leading to the next program? What do you think of the contribution coming from this project? Matured technology is something that you could do whatever you want to do in the desired way at the desirable timing. So whenever you think this initiative need to be done, and we will be able to materialize that, make it happen under a control level of risks, or maybe acceptable risks. And you have a room for decision to decide whether or not to go ahead with that. In that mindset is quite important. No one had ever had this type of options, and this is the type of decision made for the first time in the world. And of course, we are willing to continue on with the sample return mission. Our experience this time will be quite useful when we prepare for the future mission. We are going to be able to do whatever we want to do in the desirable way, which we believe so, and whatever the preferred timing, we will be able to do so. So I think the level of mission is elevated a step up, and this was not simply the technical decision. It was an organizational decision. This is the technological and pure, genuine scientific decision as well. Many factors are integrated each other, and Hayabusa2 in this particular circumstances, and we were able to make clear decision of go ahead with the touchdown too. That will give us a great example, actual example of this activity. Are you referring to conducting in sampling or whatever the missions that you're going to have? This experience will be useful. My intention is not limited to sampling only. This type of decision will be required in every case, because exploration mission will always visiting the new place. Therefore, we are in the position to make the decision without knowing much, because it is the first initiative. For Hayabusa2, we were able to do this touchdown second time, which means that we don't have to be cornered to a challenging situation. We could actually very rational and calm and decide on whether or not we should go ahead with a second round of touchdown or not. So that's the type of decision which we made. So visiting to the new place and making a new challenge, that's the nature of the exploration. However, on the other side, we were able to have this go, no-go option, and that is a great experience. Another question. There were some meeting back in June. You were wondering about some big questions. And what were the most difficult time that you had experienced so far in this program? And were you ever had a time where you almost give up the second touchdown? Or maybe you were leaning toward the opinion of not conducting the second touchdown? Well, I've been struggling all through this period, so I cannot point to a particular peak of the difficulty. But it is not just me, myself, but of course me included. Even prior to the touchdown first, we were always thinking about and wondering about what to do with the second touchdown. When we arrived at Ryugu, it was extremely difficult place. It was revealed that Ryugu is a quite difficult place. So in such a situation, touchdown was becoming feasible. And what I thought was that can we really secure the energy to be able to secure enough energy to conduct touchdown 2? In order to lead to the second touchdown, Well, earlier, a pinpoint touchdown should have been done at the third round. However, we decided to do that in the first round. Well, in a way, we had no choice but to do this pinpoint touchdown during the first touchdown. However, there was some plan that we front load timing a pinpoint touchdown. And although there is a crater, we need a pinpoint touchdown. And if we were able to overcome the pinpoint touchdown, we were able to resolve one particular challenge for the touchdown too. And that's why we exercise the pinpoint touchdown for the first round. And after that, having experience of pinpoint touchdown and discussion with all members, we were very all confident that we were able to do the second pinpoint touchdown in the TD2. So I think that we were able to organize that program quite well. So during the first touchdown, pinpoint touchdown, you had some idea of the second touchdown. That is correct. Then the person at the camera stage, please. And VS, this is Saito, several questions. Earlier, you mentioned that sample collector lead was officially being closed. After that, what is the timing of migrating to the capsule? Could you tell us the timing? We are still planning for the movements to the capsule, so we have not decided on a time. Well, as time progresses, then the risk of having some issues or troubles on the side of Explorer will be higher, although the total risk size is very small. So therefore, at the earliest possible timing, we would like to migrate the samples to the capsule, but we have not decided on the time. Second question. You have completed the second touchdown, so you were able to complete the touchdown operation of Hayabusa2. Now, when you return from Ryugu, when you start preparing for the return, probably sometime until November, were you thinking about some kinds of observation efforts or challenges or something that you need to go through? If you have some item list, could you share with us? Maybe Professor Watanabe or project leader Tsuda, please. Well, scientists are very greedy. Once we accomplish one step and we have more to do, well, ISIS people, don't we do this and that? And when you ask like this, and I'm very happy to tell you everything, but on the other hand, ISIS members are very tired. Well, until the timing which we start to prepare for the return in December, we have more time. I hope that we can do more interesting things. What about it, Project Manager Tsuda? Well, once we finish the touchdown too, my feeling is that we were able to overcome the largest, highest mountain so far. So we are feeling a little bit of a feeling of loss because we have accomplished so much. So we need to ensure a very assured operations going forward. But if we end up having a shorter period and we only be able to stay 6 months forward in Ryugu, and we cannot waste the time. So I have to say that today we made a big juncture of operation once. We accomplished so much and we need to think about the future going forward. There are some proposals in regard to the further researches. How we're going to conduct this is to be discussed among the team. We should not waste even a day, and we'd like to operate Hayabusa quite well. Now, proximity observation of the pinpoint touchdown for this time around is going to be happening at 11 o'clock. You mentioned that there will be proximity observation as well. Yes, because we have just finished the touchdown like we did for the touchdown first. It is not that we were approaching to the surface and monitor. It is more of observation from home position. So it is far away, but from the home position, we will be monitoring around the touchdown area. Maybe we might fly slightly lower in altitude and observe at the touchdown point. It is not a critical operation. We did such operation after the first touchdown. We have descent to the 5 kilometers from the surface, and we have monitored the situation after the touchdown, and we intend to do the same this time as well.
So we have time constraints. If I could ask you to ask only one question per person, and I will point to 3 people. The person on the far left and the person next to that person on the far left. Hatanaka from Nippon Broadcasting. Congratulations on this occasion. And talked about cautious opinion before. At the beginning of this week, Dr. Kuninaka they expressed a thought as a message, and I think Dr. Kuninaka was somewhat worried initially. But have you talked with Dr. Kuninaka? I haven't talked with him yet. What are you going to say if you see him? I would say, see, it all worked out. That's what I would say. And just one point. Did you do anything like you didn't eat too much the bread clump pork? Yes, I ended up eating too much, hoping for good fortune. So I ended up eating a pork cutlet, which was more expensive than normal. But I'm very happy that everything worked out on this occasion. Yes, the person next, Sugimoto from Asahi Shimbun, a newspaper. I wanted to confirm about low altitude operation. So at the altitude of 30 meters, so it's 9:54, and the camera was opened at 10. And a minute after, you were able to capture the target marker. I felt that it was very quick. Yes, the spacecraft, we were able to guide it as intended. We had several minutes allocated, in fact 4 minutes for the locating the target marker. But we were able to locate the target marker within a minute. And we have done this type of operation many times in the past, and we have been able to do the guidance in an extremely accurate way. So when the camera's eye opened, target marker was there. So we think we have been able to operate with high precision. What was the reason for this? Well, it's not just a member here. In particular, those people in the controls and those people in the attitudes. Some people are betting their life on improving the precision there. These people basically did not make any compromise in their pursuit for increasing precision, and I think that has led to the result. Final question, this person here. My name is Sete from the Kyoto News, and Dr. Tsuda. You have gone over the biggest the peak now. And the Ryugu that has a major struggle so much. If you were to say one word to both, what would you say? Well, first of all, to Hayabusa2. For us, Hayabusa2 is one of our teammates. And less than 30 meters of altitude, Hayabusa2 thought by its own and acted in the way we thought, and he made the judgment well and moved accordingly, and before being able to say thank you to Hayabusa2, we have sent a lot of instruction to send back data, but continuing to listen to our demands and requests. So I want to say thank you to Hayabusa2 as one of our colleagues. Ryugu to Ryugu. And I'm very apologetic for the fact that it was very tough on us. But Ryugu is also one of our colleagues, one of our teammates. And thank you for handing over a sample to us. A sample was handed to us, so we will take good care of the samples, and we will do the analysis with due care. So that's what I wanted to say. I'm sure there are other people wanting to ask questions, but the time is up, so we'd like to conclude the press conference. And for those people who were looking or watching the program through the internet, thank you, but we would like to close the program. Thank you very much. Just the closing remarks. I think the broadcast has concluded, but this is my comment to the